Hi friends, in this video we are going to talk about analytical method validation, especially the linearity test. Are you doing linearity validation in analytical method correctly, or are you really linear? For us, the Bible of analytical method validation is ICHQ2R1. So in this video we are going to discuss about uh, what is written in ICHQ2 about the analytical linearity method validation, or can we do that differently? Is there any disadvantages or any issues with the current ICH guideline? So before going to that one, we should know what is linearity. Linearity is nothing but it is an ability of an analytical procedure within a given range and to obtain results that are directly proportional to the concentration of analyte in the sample. So in a simple way, your results should be directly proportional to the concentration within a particular limit. How do you test linearity? There are two ways to check the linearity. One, we keep your test sample concentration as the constant, and then you spike with different concentration of standard. Another way, you are not adding the standard into a test matrix, but you are changing the concentration of the test matrix. First case, you are keeping your concentration of your test matrix as constant, but you are spiking with the standard to get a linear solution. Second thing, you just change the concentration of test solution so that the end you are getting a linearity of concentrations. Both way we can do the linearity. The only thing is that the linearity, it can be evaluated by visual inspection of a plot of signals as a function of analyte concentration or content. So your x-axis will be the concentration, and the y-axis can be anything which is giving a value or response which is directly proportional to the concentration. So what ICHQ2R is talking about guide of linearity, it is telling that following parameters to be submitted for linearity. ICHQ2 is telling that following parameters to be submitted for linearity. First one is the correlation coefficient, y-intercept, slope of the regression line, a residual sum of the squares. These four values should be submitted. It is not telling that what is the specification for the correlation coefficient, what should be the y-intercept. It is only a guideline. And also it is telling that a plot of data should be included. So you have to keep a linearity plot data and correlation coefficient, y-intercept, slope of the regression line, and residual sum of the squares. And also ICH is telling that analysis of the deviation of the actual points from the regression line may also be helpful. In the next slides, we are going to talk about what is exactly that one. So also ICH guideline is telling that for establishment of linearity, a minimum 5 concentration is recommended. Other approaches should be justified. Say for example, you are taking only 4 concentration, then you should have justification. ICHQ2 is not providing any acceptance criteria for above parameters. Now we'll go and see how we are going to plot a linearity curve. Before that, we should see the typical range. For an assay method of an APA or drug product or any assay method, normally we'll take 80 to 120% of test concentration. Say for example, my test concentration is 100 ppm, so my range will be in between 80 ppm to 120 ppm. For an impurity method, say using HPLC or GC, my linearity range will be from LOQ, limit of quantification limit, to 120% of the specification. Some of the people are doing 2 times of the specification. For example, your limit is 1%, then your the top concentration upper concentration you are going to measure is 200%. Now we are going to see how you are going to plot linearity curve. So this is the data available after an analysis. So you are keeping from 80 to 120 percentage. Concentration in ppm is 800 to 1200, and area responses are given. For that, what you need to do is you need to open Excel sheet. You need to open the Excel sheet. And you paste this value in the Excel sheet. Then select this concentration versus the response and go to insert. I already done thing, but just I want to show you. Go to insert. Then click on this scatter plot. So I'm sorry, you have to click on the scatter plot. So you select this one, and it is going to ask you what are the it is going to click on this click on the scatter plot. You are going to get a linearity plot like this. For getting this r square value, just right click and then put add trend line. Now this is going to open. This window is going to open. Click on display on equation on chart, display on r square value. So you are going to get the r square value, the linearity equation and r square value on your screen. This is the way by which we used to calculate the linearity. So by doing that one, you are getting. So by just clicking on this Excel sheet, you will get a linearity curve. But from the linearity curve, you are getting this many things. Say correlation coefficient value r square is equal to 0.999. You are getting, and y intercept is this equation is y is equal to mx plus c. 67.2 is the intercept, and 19.946 is the slope. So slope of the regression line is 19.946. So these three things directly you got from your Excel sheet. Now the next question is coming. ICHQT is telling that how we need to give a residual sum of squares, and also the analysis of the deviation of the actual points from the regression line. How do we do all those things? For then again you go back to your same Excel sheet and click on data analysis and select on the regression. Put OK. Now it will ask input y range. So you show input, you can write this response, and it is asking for input x range. So you select your input x range, and you can put as residuals and residual plots you can tick, and output range you can click here and you select this area. Yep. Then put enter and put OK. Now you are getting a chart, regression analysis. You can see that now your r square value is 0.999987. It is round figure. It will come as 4 times 9, which is available in your linearity curve. And then you have intercept 67.2, which was earlier you received when you got the thing, and again x and y intercept slope 19.946. and also here you can get a plot of residuals. What is meant by the residuals? For knowing that one, you should click here and just put as at data labels. It is telling 26, 28.6, 33.2. For seeing that one, you should see this label. So this is the result you are getting from a predicted equation. So if you put a column here, So we can see that the original result was 16050 and the predicted result is 1624. This result we are getting from this linearity curve. So the difference between this predicted and then original will give you the residuals. The difference is called residuals. Now ICH is telling that you should tell the sum of square of the residuals. So first we need to take the square of these. You need to take the square of the residuals. Square of residuals. So this we need to type these values into so you will get the square of the residuals. Then you can drill down, you will get the square of each parameter. Then you go and sum these residuals. So this value 5073.2 is the sum of square of residuals, and this is the residual plot where it is plotting the residual, the difference between the actual value and the value we are getting from the linearity curve. So ICH is telling that you need to submit this residual plot. You need to submit this residual plot, the value of r square value, the slope, the intercept, and you should give a value and should give value which is equivalent to the sum of square of residuals and a plot of this residual plot. This is what exactly the ICH is looking. Now we'll go back to our presentation. So the same thing I took from the Excel sheet. So you can see that 5073.2 is the residual sum of squares, and the plot of the deviation of the actual points from the regression line residuals, this plot. So this is exactly the ICH is looking. But is this making any sense to you? Is that value of 50732 is making any sense? And this residual plots is making any sense for you? For checking that one, we are seeing some more data. For example, ICH is telling that you should take a minimum of 5 points, but there is no limit for your maximum. Say someone is took 6 concentration points in between 80 to 120 percentage, say 80, 90, 115, or and then 120. So then one more the concentration point added. Now you see the sum of the square of residuals. It is becoming 11393.2. So that means this, if I'm taking 5 points, I'm getting some value. If I'm getting 6 points, I'm getting another value 7 point something else. So that means it's not making any difference for me the value what I'm going to present. And again, these values are changing. The square of residuals changing with respect to the unit of measurement. Say one instrument is giving a value in micro angstrom unit, a milliangstrom unit, and another one is giving only in angstrom unit. So you can see that the difference in the value. Say one is giving a response of 16050, other one is giving 1605 and 4 times 0, and square of residuals are by default it is increasing, and sum again is a big number. So these results actually the expectation which is giving by ICH is not making any sense for me. So what we are going to in my lab, what I am doing differently. In my lab, say for example, I am doing an assay method. First I need to see what is my specification. My specification is, say it is 100 plus or minus 2 percentage. Then the below things whatever I given is my criteria for linearity. My range should be 80 to 120 percentage. Correlation coefficient, we will keep minimum of R square value minimum of 0.3 times 9, 0.9990 as correlation coefficient criteria. Then we will report the slope. Not only we are reporting the slope, but percentage slope to response at 100% level should be close to 1% area response of the 100% level. The next slides I'm going to explain what these all values, why this is so significant for me. And second is percentage of Y intercept to 100% of test sample concentration. Area response should be less than 2%. First criteria is I will take a percentage of slope divided by response at 100% level. So that should be close to 1% of 1% of area response to 100% level. Say for me I'm getting area 100 as at 100% level. So then I should get an area near to 1 at 1% level. So then Y intercept. Then also we are taking one more test, a ratio of response factor at each level with respect to 100% level should be 100 plus or minus 2%. This is exactly of the specification. Next slides we are going to explain how we'll calculate all those things. Say for example, this is my linearity curve. So you can see that this is the linearity plot. So y-intercept is 67.2. What is meant by y-intercept? Y-intercept is nothing but the kind of response I'm getting from an analytical technique at zero concentration or blank concentration. That is the response I'm happening because of maybe it's contributing from your instrument, contributing from the reagents, contributing from the analytical technique what you are using. So that is kind of an error which can happen at 0% concentration. So we are keeping a criteria of 2% at 0% means when nothing is there in your sample test matrix, you are putting only a diluent or a blank. There are possibility of maximum an error of 2%. So in this case I'm getting 0.34 because y-intercept is 67.2 and my 100% area response is 19980. So 67.2 divided by 19980 in 100, I'm getting 0.34%. That means at 0% concentration, if at that means in 0% concentration, I will get an error of 0.34%. Now you see what is the interpretation of the slope. Slope is nothing but dy by dx. Dy y is the response and x is the concentration. So slope is nothing but the response at unit concentration. Now I'm not plotting anything at the unit concentration 1% concentration. My method is I'm putting a range of 80 to 120%. So but when I'm putting a slope, it is going to tell you what is your area at unit concentration. Now in this case my slope is 199.46. So my 100% concentration is 199.80. The ratio is coming 0.99. That means my method is, though I checked between 80 to 120%, my method is linear from 1%, maybe from 0% to 100%. That is exactly I'm getting the interpretation of the ratio of slope to 100% concentration. So in this case it is very close to 1. That means my linearity is very good. Now we are checking at the third level. In the third level, what we are doing is we'll take relative response factor of each level, and we will compare that against the relative response factor at 100%. In this case, for example, 800 is my concentration and 16050 is my response. So relative response will be the response 16050 divided by 800. So it will come as 20.063. 20 point, 20.0, it will come as 20.0163. But at 100 percentage level, it is 19.980. So if you take a ratio, it will be 100.41. 90 percentage level, again the response is 17990. Relative response factor, that is 17990 divided by the 90 percentage or 900 ppm, you will get 19.89. So the ratio between relative response factor at 90 percentage and 100 percentage, then 19.989 divided by 19.980, it will be 100.04. Now, after doing that one, I will plot a graph which is showing the relative response factor at each level with respect to the 100 percentage level. So now this is making more sense to me. So I can tell that my response at each level with respect to standard is within my error limit of 2%. So now you can see in the screen, the left side what I'm putting is the ratio of relative response factor that I calculated my way, and on the right side that is giving very clear-cut indication of how much my error is happening to this linearity, how much it is varying throughout this run. Right side I'm putting the residual plot as per ICH guideline. That is, doesn't make any sense to me. Say it is some values showing 26, some values showing minus 28.6. It is not making any sense to me. So that for the sake of ICH guidelines requirement, I can submit this one, but for proving the actual ability of my analytical test method, I need to show the linearity plot which is showing the relative response factor with respect to 100% concentration. So in summary, guidelines are only to guide you to perform validations. You can improve your validation for getting a superior response to your method that will increase your confidence level. So guys, so friends, if you are feeling that this presentation was it was beneficial for, it was helpful for you, share this presentation with your friends, and don't forget to click on the thumbs up button, and also you can subscribe this channel so that in future more and more analytical videos related to analytical chemistry I can post. Even if you don't like this video, please post the same thing. Please put on the dislike button and write the reason in the comment section why you don't like this video. Thanks for watching this video. Goodbye.